Dzień dobry, good afternoon. Polska Agencja Kosmiczna dołącza do globalnego odliczania przed zaplanowanym na czwartek startem misji Mars 2020. Bardzo nam miło, że zdecydowali się Państwo skorzystać z oferty i spędzić najbliższe kilkadziesiąt minut na wykładzie naszego eksperta. Ja się nazywam Szymon Grych. A teraz już poproszę o zabranie głosu prezesa Polskiej Agencji Kosmicznej, pana Michała Szaniawskiego.
Good afternoon, everyone. I welcome you to this special presentation by Polish Space Agency experts on the forthcoming NASA Mars 2020 Perseverance launch. I'm also honored to be joined today by Ms. Elizabeth Blumenthal of the US Embassy in Warsaw, and I welcome the Embassy's partnership as we expand our cooperative efforts with the United States. This is a remarkable period for space exploration, and the beginning of next year will be a very busy time on and around Mars. Last Monday, on the 20th of July, which was also the 51st anniversary of the Apollo moon landing, the United Arab Emirates successfully launched the Arab world's first planetary spacecraft called HOPE. It is projected to arrive at Mars around the 12th of February 2021 to celebrate the United Arab Emirates' 50th anniversary. Last week, China also launched Tianwen-1, an orbiter, lander, and rover combination with orbital insertion around Mars also in mid-February next year. This is China's first solo attempt to send a probe to Mars. Today, however, we will focus on the upcoming Mars 2020 Perseverance launch. This is a truly exciting mission, featuring the most capable rover ever sent to Mars, plus a unique technology demonstration with the first aircraft ever to fly on another planet. Perseverance is targeted to land on Mars on the 18th of February 2021. Like all of you, I'm eager to see what we can learn from all of the instruments and capabilities that will go to Mars with this mission. The better we understand our universe, the better we understand ourselves, the better we understand our past, and the most importantly, the better we will understand our future. I want to thank you for joining us today and for your interest in space matters, because in fact, space matters. Go Perseverance!
I'm sorry, I will repeat. We are glad that we have a representative of US Embassy with us today, our very good friend, Elizabeth Blumenthal. Welcome, Elizabeth. Please tell us how excited you are with the 2 days before the launch.
I'm very excited. Hello, everybody. Sorry, I probably should have figured that out and just jumped right in. Welcome, everybody. My name is Elizabeth Blumenthal, and I'm the Assistant Cultural Attaché at the U.S. Embassy. I'm so happy to be here. Thank you so much for the invitation. It's truly always a joy to cooperate with our friends at POLSA, so thank you for organizing this fantastic event. I have to say, like all of you, I'm really happy to be here because I'm just so excited about the upcoming launch, and I could not pass up the opportunity to learn more about the Mars 2020 mission from someone with real-life NASA experience who can give us the inside scoop. I was kind of thinking about this event earlier today, and I was thinking, what is it about space that fascinates us so much? And I think it's just that the unknown has always been a source of wonder for human beings. And that sense of wonder and curiosity of looking up at the stars and wondering what is out there, that's really something that has united human beings from the dawn of time until today. And we've explored space in real life with both crewed missions and also with instruments like telescopes and rovers. And we've also explored space in literature, in art, music, comic books, cartoons, pretty much every human creation ever. And what drives all of that exploration, whether real or imagined, is this innate sense of curiosity that is common to all of us. And I hope that today a little bit of that curiosity will be satisfied by John's presentation. I'm sure it will. And I also hope, if you'll indulge me for a moment, that if any of you with us here today are between the ages of 10 and 18 and are interested in comic books, that you will consider sharing your own ideas about space and the exploration of space by participating in our Comic Space Odyssey competition. You can find all the details on the Embassy Facebook page. That's the end of my plug, but we look forward to seeing your creative exploration of space in that context. So thank you all so much for being here. And POLSA, thank you so much for inviting me and letting me join you today. Thanks, everybody. Enjoy.
Thank you very much. Thanks again for joining us, Elizabeth. And now the main point of today's meeting, presentation and lecture by Mr. John Hall. For many years, an expert and specialist for NASA, currently expert for Polish Space Agency. However, at first I encourage you to send us questions to John using YouTube chat, preferably in English, ale jeśli Państwo chcą zadawać pytania po polsku, to postaramy się je na bieżąco przetłumaczyć i również się do nich odnieść. The presentation is estimated for about 30 minutes, and questions and answers session will start right after that. That will be the last part of our today's meeting. So John, the floor is yours.
Okay, thank you very much. First of all, many thanks to our president, Michał Szaniewski, of the Polish Space Agency, who is as enthusiastic and interested in all of our international and Polish space exploits as anyone could be, and I really appreciate that. I think maybe if everybody could mute who's not speaking, that would be good. And then I also want to mention my sincere thanks to our colleagues from the U.S. Embassy. Elizabeth Blumenthal represents an entire team of people from the United States Embassy in Warsaw that has been working very closely with the Polish Space Agency, POLSA, for many months on public outreach, education, and opportunities for advancement together in space. And so I'm so very grateful that Elizabeth was available to speak with us today. Before we get into the meat of the presentation, which is essentially a summary of the highlights of the Mars 2020 Perseverance mission, I wanted to draw your attention to this first slide, which has on it a picture of the plate that the team at NASA, the Jet Propulsion Laboratory, included on the Perseverance rover. And it is a tribute to all of the medical professionals, primarily and personally, who have worked so hard on addressing this COVID-19 coronavirus situation that we are all dealing with in the world. And you'll notice that it has not only the caduceus symbol that is standard for medicine with the snake on the pole, but also it has the earth topping that depiction. And that indicates the fact that we are all dealing with this. And one of the things that I hope to remind you of at the end of this discussion is that all of this that we hope will be accomplished in just 2 days with the launch of Mars 2020 has been accomplished over the last 4 months, especially over the last 5 months, with everybody having to work remotely and having to deal with the challenges of this unusual and extremely significant pandemic, which we are all confronting. And that's an achievement that I think should not pass without notice. So if we could, let's go to the first video presentation courtesy of NASA.
NASA's next Mars rover is in development and has an ambitious mission. Decades of Mars research from previous spacecraft have shown the planet not only had water in the ancient past, but had environments that could have supported life.
Mars is our neighboring planet and in many ways the most similar to us, and certainly in its history. And the question whether ancient life was there is still the question that keeps us up at night.
Mars 2020 has 2 new objectives: to specifically seek the signs of life and then sample materials and prepare a cache that could be returned to Earth by a future mission.
Mars 2020 is really the essential first part of a sample return mission. So it actually looks at the environment of these samples and then collects them and stores them. Afterwards, we will, of course, go and bring these samples back. So Mars 2020 is the first half of a return trip.
The Mars 2020 mission, to the maximum extent possible, follows the Mars Science Laboratory Curiosity mission. We're going to use very similar rocket, very similar cruise stage, very similar entry, descent, and landing. And the rover, when you step back, will look almost identical.
Not only were a lot of designs already developed for the most part, but we're also using a lot of spare hardware that we had from MSL or Curiosity for Mars 2020. If you know where to look on Lab, you can walk around and see a lot of the EDL hardware and the cruise stage hardware that's already been built.
And this is really important for understanding why this mission makes sense. We have to do relatively little in the way of new development. And this saves money, it saves risk, it saves time. It's the right way to pursue this kind of mission.
Mars 2020 also features new technologies for entry, descent, and landing, allowing it to target a smaller landing zone and even divert from known risks in the area.
It means that we can both go to places that are maybe more interesting to the scientists because we're able to handle places with more hazards, as well as land closer to the things that they're interested in off the bat. So we get to the science that they care about and more quickly.
The 3 key sites that we are considering right now share one thing in common. They are all environments that might have been habitable in the very distant past. One of them is the floor of an ancient lake. Another is a hot spring. And the third one is a site where hot water interacted with rocks in the shallow subsurface. We have instruments on board which are expressly designed to seek evidence of ancient life, what we call biosignatures. And we have the capability to prepare samples, drill them out of a rock, seal them in a tube so that a future mission could go and bring them up. We call that caching.
So it is a first of a new type of mission, which is to bring samples back to the best labs we have, which are here on Earth. Mars 2020 is a pivotal mission in our search for life that could finally answer the age-old question, are we alone?
NASA's
Okay, so let's go to the next slide, please. I just want to highlight a couple of things before I get started on this about what our president, Michał Szaniewski, mentioned about the United Arab Emirates and the Chinese missions that were both launched within the last week. Mars is going to be a busy place in February of next year, and I think that's great. I think we should all think that that's great because one important lesson that every spacefaring nation knows is that no country, not the United States, not Russia, not China, not even the European Union, has cornered the market on space talent, and so seeing a multitude of missions arriving at Mars in February of 2021 is actually something that should be celebrated. And so, just with that, and I'll also mention, if I may, that the United Arab Emirates mission is fairly notable for the fact that it features a very significant role of Emirati women in building it. They comprise 34% of the mission team and 80% of the science team. So I think that's something that we can celebrate as well. Of course, we know that there was going to also be a fourth mission this year, which was the European and Russian lander rover ExoMars, which was supposed to launch this year, but had been delayed until 2022. The next time that the Earth and Mars are in alignment, and it was delayed most recently as a result of the COVID-19 pandemic. Mars is hard, and so I think it's worth taking note of all of these missions. But let's talk about what Mars 2020 is. So it's NASA's next mission to Mars. It's intended to launch from the Cape on Thursday, the 30th of July, around 7:50 a.m. Eastern Daylight Time, which would be za 10 druga u nas w Polsce, on a United Launch Alliance Atlas V 401 launch vehicle. It's you saw that in the video that there were 3 landing sites identified. The one they're going to be landing at is the Jezero Crater in February, targeting the 18th of February of next year. It is, in fact, the most sophisticated rover that NASA has ever sent to Mars. It is armed with over 20 cameras that capture both color images and high-definition video, and for the first time ever, microphones, so that we will be able to hear the sounds of Mars. So that's significant. There's a lot of firsts and a lot of superlatives associated with this particular mission to Mars, which costs about almost $2.5 billion, or about €2 billion to bring off. So we obviously hope for success. I think there are really two things that the mission is looking for. First is they're searching for life. I mean, we've always been searching for life in one way or another, but this mission is laser focused on searching for signs of microbial life and proving that, which is extremely hard. And I think that the second thing that is a significant goal of this mission is proving technologies and techniques that will enable human exploration on Mars beyond the moon. And so I think those are kind of principally the two objectives. NASA has never said that. No one else has ever said that. But that's kind of what I discern from all of this. And of course, there's a helicopter stunt that we'll talk about in a minute. So let's go to the next slide, please. A little bit of a recap here. When it lands on Mars, the Jezero crater is actually the site of an old river delta in a lake area, and that's rather significant because if you're trying to prove that life once existed, you want to find signs of life in minerals that are known actually to preserve those signs of life. And sedimentary rock, iron-rich rock, silica, and carbonate rock that might contain and retain and maintain those symbols and signatures of previous life are most important. And these were actually identified by the Compact Reconnaissance Imaging Spectrometer mission that was launched in 2005 as part of the Mars Reconnaissance Orbiter. So we had a mission 15 years ago that has served as the basis for selecting this site. And I was just noticing on our chat questions, how are the goals of the mission picked? Who decides what to discover next and where to send the rover? Well, you build upon that information that we get from all of these other sources, like this orbiter, the Mars Reconnaissance Orbiter, and this CSIRM instrument, to tell us what's the best place to look for evidence of life. And like I said, I think there are two key objectives for the mission: finding evidence of life and proving technologies and capabilities and techniques for human exploration. So let's go to the next slide, please. Now, the science on Mars 2020 is just fantastic. There are principally 7 instruments that the rover is going to be carrying, apart from the Ingenuity helicopter, that are so significant. And I've broken them up here into 2 separate categories. One focuses on basic science, and the next is focusing on applications for human habitability. So we've got the Mastcam, which is an extremely advanced camera system with panoramic and stereoscopic imaging, which we have seen on some previous rovers. As you saw in the film, there's a comment that we tried to build upon technologies that have already been proven on the surface of Mars, but also to help with the mineralogy and determining just the composition of the mineralogy on the Martian surface. Then we've got the SuperCam, which is impressive because it actually provides remote analysis of mineralogy and chemical composition rather than actual direct analysis, which we will get to in a minute, and which is actually one of the things that, for example, Poland's contribution to the Mars InSight lander, which is currently operating on Mars, is intended to provide with its drilling and retrieval of direct mineralogical and chemical composition analysis. There's also Pixel, which is an X-ray spectrometer, which will give us a much better view of the elements in the Martian surface than we've had previously. And then this neat thing called Sherlock, which is the very first ultraviolet spectrometer to visit the surface of Mars, and will be extremely valuable for very fine, detailed imaging using ultraviolet lasers and ultraviolet spectrometers to analyze organic compounds. And that's something that's kind of neat. For those of us here in Poland, it's kind of the second step from the instrument that Poland provided to NASA for the Mars Curiosity mission, which is actually still running around Mars, where Poland had a sensor on there that was sort of a previous generation of something like this. So let's go to the next slide. And so on this part of the science part, I wanted to focus on the remaining three principal instruments, science instruments, that more or less drive us to solutions for human exploration and human habitation on Mars. The first one is MOXIE, and this is a technology demonstrator that is intended to produce oxygen from Mars's atmospheric CO2. And that would be extremely valuable for a whole variety of applications, not just for human sustenance, but also for propulsion. And then there's MEDA, which is a set of sensors that will provide basically Mars climate information that will be essential for human activities on Mars. And then you've got RIMFAX, which is a ground-penetrating radar that will give us some information about, at very good resolutions, at very small resolutions, of the nature of the subsurface for things like infrastructure and habitability on Mars. So let's go to the next slide. We'll talk a little bit about the stunt that Mars 2020 will provide. I call it a stunt, but I say that rather tongue-in-cheek. This is nonetheless a significant technology demonstration. But you'll see at the end of this discussion on this slide why it is that I call it so. But Ingenuity, a small helicopter, which has enormous blades and extremely small mass in order to try and get it off of the ground due to Mars's limited atmosphere. It is nonetheless going to be the first aircraft to attempt controlled flight on another planet. And I saw from the questions on the chat, why would we want to do a helicopter and not a balloon? Because a helicopter would seem a lot harder to do than a balloon. And what we're looking for is controlled flight. And we're looking for the opportunity to demonstrate controlled flight capabilities that human beings could take advantage of once they're on Mars. Truthfully, the first success of the Ingenuity demonstration will be its ability to even make it through the night. Mars, of course, has temperatures that are significantly more challenging than those here on Earth. And so if it survives it just through the first night or so, it'll be something of a success. But what's notable about this, I guess, is one thing in particular, which is this is not the kind of technology, this is not the kind of aircraft that one could operate with any sort of immediate joystick capability, for example. The fact of the matter is that this helicopter has to be capable of autonomous flight. So commands will be sent in advance, and then the data will have to be returned afterwards through the orbiting Mars spacecraft, the orbiting observers and reconnaissance spacecraft, because this thing, to some extent, is going to have to operate largely on its own. I did want to. I called it a stunt because this is not the first time, not nearly the first time, that NASA or in fact anybody on Earth has ever thought about flying an aircraft of some sort on Mars. People have been thinking about this for 100 years almost, including Werner von Braun, big name in NASA history. And in space history generally. Most recently, in the 1990s, under the Golden administration at NASA, NASA seriously proposed a Mars airplane, which is depicted here on the bottom of the slide, to celebrate the centennial, the 100th anniversary of the Wright brothers' first flight in 1903, because that mission would have flown in 2003. And that was called the Ares Mars airplane, but it was not actually selected for flight. So if Ingenuity works, why, it'll be the first demonstration and probative attempt of a controlled flight on another planet, and that's nothing to sneeze at. So let's go ahead with the next video, please. Okay, is it okay to jump in here? I think that the video has shown. Got a question on the YouTube chat about how much oxygen can Moxie produce? Okay, so the answer to that is if it functions as designed, Moxie, and we'll talk about that in a little bit more in a second, but Moxie can actually produce 22 grams of 99.6% purity O2, oxygen, per day. So that's, is not a lot. I'm sorry, per hour. Going off off an assessment that came from JPL. From the Jet Propulsion Laboratory. So 22 grams of oxygen per hour at 99.6% purity. Again, nothing small. So we'll see how it goes. That's JPL's prediction on Moxie. Anyway, I did want to mention. While Poland is not specifically involved in this particular mission, there are several European partners who are contributing instruments to the mission, including CNES in France and INTA in Spain. And also we've got help on RIMFAX from Norway. However, in addition to that, there are more than 250 scientists from across the planet who are engaged in the mission. So that is something I think for all of us to celebrate. Again, recognizing that no country, no company, no individual has a corner on the market in space talent. And I think that's an invitation for those of us here in Poland and across the planet to get involved and to participate in space exploration and understanding our space environment. Okay, we'll go to the next slide, please. So, sort of wrapping up, what are the next steps? Perseverance is actually just the first leg of a round trip to Mars. As I said, I think there are really two things that the mission's trying to prove. One is to somehow fulfill the burden of proof of life on Mars at some point. And the way to do that is going to be obtaining samples that can be returned to Earth, because the best laboratories available for analyzing those samples cannot be transported to Mars, nor can they be transported to the moon. They exist here on Earth. And they require special preparation and precautions and things like that. You're worried about cross-planet impurities and things like that that sort of demand that you have very, very capable and secure facilities for that. And those only exist here presently on Earth. So bringing back those samples is a huge part of it. The second part of it, the second part of the mission, as I mentioned, in my opinion, is, of course, testing, proving, demonstrating capabilities and techniques for human exploration and life on Mars. There is, of course, a campaign already underway by NASA and the European Space Agency, ESA, to do just that, to bring back those samples. And it would be a Mars sample return mission. that could occur in the next couple of years at the earliest point. But that would be the next step in demonstrating the evidence of ancient life on Mars in a truly compelling fashion. One of the things that I wanted to mention here, and it's not specifically part of next steps of Mars 2020 specifically, as much as it is of all future planetary exploration, is just this capability that was mentioned in the initial video, in the first video, which is called the Terrain Relative Navigation System, which I think is just fantastic. This is a system which allows the lander, before it has touched down, as it's on its way down, to autonomously understand where it is and what it is about to encounter, and to make changes in its trajectory during its descent. It's quite similar to seek and avoid technologies that we use for aircraft, for drones, and things like that here on Earth. And its application on Mars, I think, is just something that's very remarkable. And I think it will have enormous impacts for future missions, both robotic and crewed, not only for Mars, but for the moon and other places. So I just mentioned that Terrain Relative Navigation System as something that I find extremely impressive. Next slide, please. So I think I've talked. I've said more than once. The Perseverance rover and the Mars 2020 mission is just chock full of firsts and superlatives. It's the first. If the mission is successful, it'll be the mission with the first microphones on Mars. It'll have the first controlled aircraft flight on Mars. It has essentially the best capabilities of any rover that has ever been sent to the Red Planet. Engineers have given Perseverance more self-driving smarts than any other rover, allowing it to make decisions for itself and not having to stand by for instructions from folks here on Earth, which take much longer both to review, process, and return with following instructions than is otherwise possible. I mentioned MOXIE, and we had the question about how much oxygen that produces, and I think that is a remarkable experiment. I think it will have application for a great many uses, assuming that it is successful on another planet. And then understanding, the climate on Mars and the weather on Mars, so that when we ultimately do have people there, they don't get caught up, the way that Matt Damon did in The Martian, in storms that have unhelpful effects. So that is. That's my assessment of the next steps for the program, and I think we'll close out with a final video, and then I'll try and answer the remaining questions that came in on YouTube. And I thank you, and I thank our president and our guests and our co-host from the U.S. Embassy, Elizabeth Blumenthal.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We are go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Okay, so Shimon, should I go ahead and try and answer some of these questions?
Please go ahead, John.
Okay, so Shimon, should I go ahead and try and answer some of these questions?
Yes, John. Can you see it on your screen, or should I repeat some of them? There were a few questions on the helicopter, especially.
Right. So I think I have, if you're talking about what showed up on YouTube, I have written them all down.
So it's all there is.
Okay. All right. So, yeah, so we talked about why a helicopter as opposed to a balloon. Well, we're looking for controlled flight, powered flight, right? And what was important in 1903 that the Wright brothers did was that it was a technological step that was far beyond technology that had been actually demonstrated more than a century, actually more than 2 centuries before with balloon flight. The ability for controlled powered flight is what they're looking for. So that's why they're not both the airplane concept and the helicopter concept are controlled powered flight, whereas a balloon, while it can be controlled to certain degrees, is not the same. So that's why the helicopter route was taken. There was a question about what range could the helicopter potentially operate? So not very much. As we understand it from JPL, it can fly about 10 meters in altitude for about 300 meters downrange. So we're not talking about significant either distance or altitude, but it is what it is. Let's see. Somebody asked, does POLSA contribute? I think I already answered that. That on this particular mission, no. But be aware that that Polish entities have made significant contributions to two very important existing Mars missions that are currently operating, both Curiosity with an infrared sensor and Insight with the CRET penetrator, ground penetrator. So I think that's something that should be recognized. Let's see. Will there be a video camera mounted on the sky crane looking down on the rover? I suspect it would be tricky to downlink the video data from it, considering the maneuver's pace. Well, okay, so that question came in a little bit ago, and here's what I have to say in response. The answer to your question most directly is, I don't know. However, what I do know is that the rover is actually equipped with cameras that can record its entry, descent, and landing. Okay, so there may not be. I simply don't know the answer. I have to tell you, I don't want to make something up. I simply don't know the answer whether the sky crane has that capability, but the rover has the capability to project, to actually record and project imagery from its own entry, descent, and landing. Again, another one of these firsts that are so impressive about this mission. I see we got 5 minutes left, so let me see if there's something else. Oh, how could Martian weather impact helicopter flights? Well, the same way that weather here on the Earth impacts helicopter flights. So I think that's probably the easiest response. What are the biggest risks of the mission? That was the last question that I got. What are the biggest risks of the mission? I think the answer to that question is, how much time do you have? There are so many risks to a mission like this. Obviously, there are launch associated risks, right? The Atlas V blows up on the pad. They have to do an abort, mid-launch at any point. Once it gets going, you've got. Just remember, this mission is flying on an Atlas V 401, which uses RD-180 engines that are Russian technology, quite good, by the way, excellent liquid engines that produce more than 800,000 pounds of thrust. They've got 4 SRBs. They've got 4 solid rocket boosters, each of which gives you more than 200,000 pounds of thrust. So there's more than 2.2 million pounds of thrust of this baby when it leaves the pad. And it's the same type of propulsion that we needed to get, for example, New Horizons to get out to Pluto, and which is now going interstellar. You're just talking about an enormous amount of power that that potentially places the whole shooting match at risk. Everything can go away in just a heartbeat. But assuming everything works through the final stage separations, you're then talking about a final stage that is moving at 45,000 miles per hour or kilometers per hour, which is 26,000 miles per hour, which is incidentally about the fastest that anything has ever traveled in history. And so who knows what you could encounter at 45,000 kilometers per hour that could wreck the whole deal. And then when you get into the Martian orbit, or early mid-February, and you're trying to set everything together to begin the entry, descent, and landing stuff, there's just so many things that could happen, that could go wrong. And then, of course, we could have a situation, like the Soviets had, where they had landed a lander on Mars after going through a whole bunch of stuff. This was a couple decades ago. And 20 seconds after the thing lands, all communications go off, right? So you can have, all sorts of problems. Mars in particularly is very hard. There have been over 60 missions attempted to Mars. Less than half of them have been successful. More than 20, almost 25 of them, and a third of all Mars missions have been NASA missions. And more than 20 of them have been NASA missions, but it's very, very hard to do this stuff. ESA's had a few, the Soviets had a few, India had one. So the UAE and China are now on the way to hopefully some successes there, but Mars is very hard. So when you talk about the biggest risks of the mission, I think you just have to allow yourself an opportunity to say, boy, there's just a whole bunch that could go wrong here. And you rely on the competence and the ingenuity and the capability and the faith of everybody who's participating in it to make it happen. Let's see, there was a final question. What potential evidence of extraterrestrial life are you looking for on Mars? Okay, so I guess I'll treat that as the last question. Specifically, the mission is seeking signs of microbial life in mineralogical samples. That is, we are looking for evidence of life in rock, and we're looking for, the world is looking for evidence of life in rock that is sedimentary, that has been in places that we believe contained water, because that offers the greatest potential for proving that. So, so with that, I think we've reached our time, and I want to once again say thank you to our hosts, Shimon, for doing such a great job. I want to thank our co-host, Elizabeth Blumenthal from the U.S. Embassy. I want to thank our president, Michał Szaniewski, and I want to thank all of you for taking the time to check in. As Michał said, it's great that everybody's paying attention to Space Matters, because, in fact, space matters. Dzięki.
Thank you, John. Thank you, everyone who was watching us. Thank you, Elizabeth. And please stay tuned for our further events online or in real time. And we probably see each other during the countdown on Thursday. Dziękuję bardzo Państwu. zapraszamy ponownie na nasze spotkania.